All right, folks. So a couple of algebra topics in particular are really show up throughout this course. One which we emphasized here recently was systems of equations. Again, an important thing with systems of equations is being able to make good decision making, knowing when to use elimination versus substitution can really make problem solving more efficient. Another topic that's a big deal is going to be factoring quadratics, being able to do so efficiently, whether the leading coefficient is 1 or not. So this is something that these two topics you're going to see regularly. And if you really struggle with either one of these, don't hesitate to come by and see me during office hours or set up an appointment or utilize the Academic Assistance Center just to make sure that you're up to speed on what you got to be able to do. Now, the left-hand column, this is mainly just GCF stuff. I'm just going to talk about the first one. Remember, GCF stands for greatest common factor. You should always take out the GCF first. Here, the GCF in this one is you can take out the lowest power present of the variable. So you see this k squared, k to the fourth, k squared. So there's at least k squared everywhere. There's at least m to the third. So what does that leave here? Well, it leaves nothing, but you don't leave it blank. 4k squared m to the third times 1 would give you this. This, of course, would be 2k squared. And this would be, sorry, that should be a minus. This should be minus 3m. That's just GCF stuff. If you want to mess with 2, 3, and 4, you can. You can check my solutions later on. They'll be posted as well. I do want to focus on the right-hand column and then the back side, plus a couple of additional problems. So when you factor here, by the way, notice how all these problems on the front side, they don't have an equal sign. They're not equations. They're just expressions. So we're just factoring. But you always want to take out the GCF. In this case, if there is one. In this case, the GCF is 6. So we have a squared minus 8a minus 20. Taking out the GCF could potentially make life way easier for you. Now you want to factor this quadratic. Remember, these first terms have to multiply to give you this. That's going to be a times a. These last terms have to multiply to give you this. So we have a bunch of options, right? We could do 4 and 5. We could do 10 and 2. We could do 20 and 1. But they have to be written in such a way that this inner product and this outer product combine to give you this. And this is going to be 10 and 2. Watch what this tells me that the signs have to be different because these two numbers have to multiply to give me a negative. This tells me that the bigger of the inner or the outer has to be negative. So it's going to be like this. Now I always do a quick mental check at the end. Look at this, negative 10a, positive 2a, that gives me negative 8a. That's it, okay? Now this one here is harder because there is no GCF. So we have to go straight to our double parentheses, and we have a couple of options in the front. It could be 6 and 1. It could be 3 and 2. Let me kind of talk through this. I'll try to do 6 and 1. I'll write that down. Now on the back side, it could be 6 and 1 or 3 and 2 as well. And we just have to play with this. This is called the guess and check method. If I do 2 and 3, this is going to be 18 and 2, which does not add or subtract to 5. If I switch it around, put the 2 here and the 3 here, I get 12 and 3. That doesn't make 5 either. If I try 6 and 1, I get 36. That's way too big. And then if I put 6 here, I get 6. That doesn't work either. So 6k and k doesn't work. So that means it must be the other one, right? 3k and 2k. Now let me try 6 and 1 here. 6, 1. That would be 18 and 2. Does not add or subtract to 5. Try the 6 here. 12 and 3 doesn't work either. It's going to be 3 and 2. Watch this. So 3p and 2p. See, this gives me 9pk. This gives me 4pk, and that actually subtracts to 5. So signs have to be different. Make the bigger one positive. Positive 9 kp, negative 4 kp gives me positive 5 kp. Negative times a positive is negative. We're all good. This is the difference of squares. Okay. So these are both perfect squares. There's only two terms. It's just a binomial. There's subtraction in between. This is just the square roots. 4p and 4p. 5 and 5, make 1 plus, make 1 minus. You see, that way these middle terms cancel out. 20p and negative 20p, there's no middle term. Again, GCF always. So this would be 16a squared minus 24ab plus 9b squared. Now, what I tell my algebra students when they see this is it doesn't always work, but if you see a trinomial like this with perfect squares on the ends, go ahead and try those square roots first. This is why we have pencils with erasers. But sometimes it doesn't work, but a lot of times it does. Let's see here. This gives me 12ab. This gives me 12ab. Together, that can make 24. Signs have to be the same. They're both negative. Turns out it works. I went kind of fast there, but you should be pretty comfortable with that. If not, feel free to come in. We can talk about it. Now, on the back side, we're getting into the solving. Okay, we're getting into the solving. So there's some different techniques here. In this first problem, notice how there's no b term. There's no plain x term. There's just x squared. So in this problem, we just want to get x squared by itself. Move the 16 over. And I'm getting ahead of myself here. Remember, when you solve this, you actually get... Okay, I got some weirdness going on. Let me see if I can get this thing working again the correct way. So we get x squared equals 9, and then we get x equals, remember, it's positive or negative 3. So you isolate x squared and then take the square root when there's no b term, okay? But when there's a b term, well, we'll see that in there in a second. Let's take out the GCF here first. The GCF in this one's not just 3, it's actually 3x, which leaves us with x squared plus 4x plus 3. Now, here there is a b term. You see that 4, so we're going to use a factoring method. Well, let's go ahead and factor that. Remember, we're not even looking at the 3x in the front net right now. So we have a leading coefficient of 1. This makes our factoring easier. We're going to do 3 and 1. They're both plus. But we actually have to give the answers. This is asking for solutions. What value in here makes this parentheses come out to 0, negative 1, negative 3. And whenever you have an x in the front, you're going to have an answer of x equals 0. Okay? Let's, here, this one, there's no b term. You're just taking the square root here. Of course, the square root of 1/4 is 1/2. Here, there's a couple ways of doing this, but I would just say, hey, there's no b term. I would get x squared by itself. So I get 16 over 9. Take the square root. Turns out that it's a nice, perfect square, so that makes it easy. I'm hoping that this, doesn't seem to be totally new to you. Sorry about this. This one's a little bit harder. There is no GCF, so we just have to play around with it. The good thing is that this first number is prime, so it has to be 5x and x. We have a couple options on the back side, 6 and 1 or 3 and 2. You can quickly eliminate 6 and 1 because that would give you 30 and 1, or 6 and 5. It doesn't make 7. But if I do 3 and 2, now it does matter where you put the 3 and the 2. If I put 3 here, I get 15 and 2. That's not going to make 7. But if I do it like this, you see I get 10 and 3. Signs are different. Make the bigger one negative. So we got negative 10x and positive 3x, which is negative 7x. I'm good. My factoring's excellent. Don't forget to give the answers. Now the shortcut here is don't just write negative 3. That's not right. That doesn't make this set of parentheses come out to 0. It's this over this, change the sign. And where did that come from? That comes from the fact that we need 5x plus 3 to equal 0. We move the 3 over. That's where the opposite comes from. And then we divide by 5. That's where the over comes from. And this problem here I want to talk about for just a moment. Just make sure you're comfortable with squaring these radicals. So when you square, that square gets applied to both the 5 and the root 3. So 5 squared is 25. Remember, root 3 squared is plane 3, because root 3 times root 3 is root 9, and the square root of 9 is 3. So you have to do 25 times 3, which is 75. This, of course, would be 5. We get 80. Now remember, you can't leave it like that. Okay, we have to take the square root of it, and the square root of 80 can be, should be plus or not minus. Biggest perfect square that goes into 80 is 16. It goes in 5 times. So our final answer would be square root of 16 comes out as plane 4. There are no perfect squares that go into 5, so we're done there. Okay. Ideally, you find the biggest perfect square possible that goes into those things. All right. Now, I got a couple more things, like 3 more things I want to show you. We'll just kind of write them in here. Maybe you try this yourself, but if you want to just listen to me, that's fine. You can stop. This is a video. You can stop it as much as you want, right? Or you can just say, forget it, Mr. Sazik, I'm never going to watch these again. It's up to you. Okay, so here, I hope you remember, before you do any factoring or solving, when you have an equation that has multiple different x terms in it, you want to be equal to 0. So my recommendation is you always move things over to the side where the biggest power is positive. You see this 12x to the third is positive over here. So let's move these other things over to this side and set it equal to 0 that way. I always want my leading coefficient to be positive when I'm factoring. I'm going to take out my GCF, which is 2x, 6x squared plus 13x minus 5. Now, I don't look at that 2x when I'm doing the next step. This one's a little bit of a pain because I have a couple options here. But remember, I only have one option here. It has to be 5 and 1 because that's prime. So on the front, I'm messing with 3 and 2 or 6 and 1. I am going to have to do 3 and 2 like this because you see this gives me 15x, that gives me 2x. That one's plus, that one's minus. That combines to that. Don't forget, you write down all 3 answers. Negative 5 over 2. This would be 1/3, and that would be 0. Now, you only get that 0 answer if you have an x in the front. If it's just a constant in the front, like the number 2 or 10 or whatever, there is no additional answer. It's only when you have an x in the front. Okay? All right, I got 2 more problems. So this one here, let's go ahead. X squared minus 2x minus 4 equals 0. So this one doesn't look too bad, right? I mean, there's no GCF, numbers are small. You set up your double parentheses, and you realize that the factor pairs of 4 are 4 and 1, and that's not going to add or subtract to get me this middle term of 2. You could use 2 and 2, but that's not going to give me 2 in the middle either. You actually quickly realize that this doesn't factor. Now, I will tell you, most of the quadratics that we do in this class will factor. But remember, if it doesn't factor, it doesn't mean you can't solve it. This would be quadratic formula. Yeah, everyone's favorite from last year. X equals opposite of b plus or minus square root b squared minus 4 times a times c all over 2 times a, right? So let's simplify that a little bit. This would be 4. Remember, we have a negative times a negative, so that becomes plus. 4 plus 16, we have that. Now, what does that become? You get this, we can simplify this. 2 plus or minus square root of 20. The biggest perfect square in that is 4. The 4 comes out as a 2. We have a root 5 left in there. Now 2 over 2 is 1. These cancel. So you end up with two answers, 1 plus root 5 or 1 minus root 5. Now, I'm not going to lie to you. We're not going to see a lot of quadratic formula this year, okay? But it is something that you should be aware of. You shouldn't have forgotten it. If you did, I need you to refresh your memory a little bit on it, and don't hesitate to ask me about it outside of class. If we need to do a little work individually, that's fine, okay? You're going to do a lot more with this next year again, but it'll come up here and there. Last problem, and this is just a simplify. These other ones were solve. This was solve, and then this one that we did here, that was solve. This one here is simplify, and it covers one topic that we haven't discussed yet. We've discussed this first one, so to simplify this, again, you break the 12 up, you find the biggest perfect square that divides into 12. In that case, it's 4. Square root of 4 comes out as 2, turns it into 8. And you're left with root 3. Nothing can go into that. Now this, we haven't talked about this yet. This has to be rationalized, 10 over root 5. You can't leave a square root in the denominator. So we multiply by root 5 over root 5, which gives you 10 root 5. Root 5, the whole purpose of doing this, you always multiply by the root over itself. Remember, that's multiplying by 1. We're not changing the value, we're just changing how it looks. And the reason why we're doing that is a root times itself cancels the root out. Root 5 times root 5 is plain 5. Now 10 over 5 is 2. And we still have this root 5. So, this stuff here was just my scratch work here. This becomes that, okay? So you had to simplify the first part, the 4 root 12, and then you had to rationalize the second part, the 10 over root 5. That's what we did. I'm hoping that rings a bell, and if it doesn't, if it's like totally new to you, we probably need to talk individually, but hopefully it's you're shaking the sand out from lying on the beach all summer and kind of getting back into the swing of things here. So that's it for that. All right.